Okay. Good afternoon, hello everyone. Yeah, this is yesterday class. Maybe before we start, I would like to know: have you checked my exercise for the limit? Okay. I already give you the video solution, so if you have any problem with the exercise, you can watch the solution. And if you have a problem with the solution, you can discuss with me. Okay, you can if you want to discuss with me. I think the limit, the one that I give you, the exercise, I think at least 3 of the questions is a little bit complicated or difficult, but eventually with our knowledge in limit, we can solve that. So take your time slowly. And if you have any other questions related to the chapter 2, please let me know which part that we need to discuss. Or at least, if you want to email, you can email me with at least the photo or screenshot which problem you think you need to get explained more. Okay, so right, I give you this part here. Anyone try to solve this one?
Yeah.
Yeah. What's the answer? Do you get? Okay, I think that. Yeah, okay. I think most of you get the correct answer. 81. Anyone solve? You get? None of you? 59. Anyone? But it's actually yeah, but I think it's already in the yeah, but I think most of you got most of you I think already get the answer. It's actually pretty similar to what we have here. The step is pretty similar, just a different numbers, different calculation, but the step is pretty similar to the right one. You will get around negative 81. Wait, let me check.
Over y.
Yeah, negative 81 over y cubed, right?
Yeah.
Yes, correct. Yeah. So this will be the y double prime should be okay. So if you have maybe something complicated here, remember that we can always substitute that with the original equation. You could get the original equation. Because to get through the negative 81, it's pretty similar to what we have here. You will get something complicated here, but actually this is the same as the original equation. Okay. So you get here. Okay, I will skip this one. Okay, I believe you are able to solve this. Okay. Yesterday feedback. Anyone still confused how to solve this?
Yeah.
Okay, still confused? Okay. Okay, now the functions is expected to be differentiable. Okay? So differentiable everywhere means that on every point, its derivative should be same. And now we are looking at the number 2, which is it has a little bit different function, right? Different equations, right? But we need to take this differentiable everywhere, which means if we take this 2, because 2 is the point where the left and the right equation will be different, then when x equals 2, its derivative should be the same. That's differentiable everywhere. So we could say so f is differentiable. Let me write the explanation here. Is differentiable for x and x. Or maybe let me write this first, okay, to get through. So for x less than 2, okay, the f prime x becomes 2x, right? So f prime 2 from the left, let me write from the left with negative here, just to note that it's from the left, okay? Differentiation from the left. This will be equal to 4, okay? And then similarly for x greater than 2, the f prime x, we are going to differentiate this. Since b is a constant, we differentiate becomes 0, right? Mx differentiate become m, okay? So f prime x is equal m. Just a constant m. So our evaluate 2, so our function here, our first derivative at x equal 2 is just a constant. So for f of x to be differentiable at x equal 2, okay, we need the differentiations from the left at x equal 2 is equal, okay, well, if you already know like the process, I think you can skip some process and write the conclusion. This is just step by step to see what is the question is actually trying to ask. Okay. So we are going to look here, and then we can conclude that this 4, this f prime from the left, should be equal with m. So we get that m is equal to 4. Okay. So we know that m is 4. So for x greater 2, our f of x, we can propose our equations that equals to 4x plus b. Okay. Now we are looking for b. Okay. After we get m, we are looking for b. Okay. Remember. Every time you have a differentiable everywhere, which means they have the same differentiation from the left from the right, and continuity. Okay, the 2 points. Okay. Differentiations and continuity. Now, after we get this f of x 4x plus b, we can also join the continuity to the whole process. Okay? So we can observe whether it's continuous, but it's supposed to be continuous, right? Because it's assumed that it's supposed to be differentiable everywhere. So the f of x is continuous. So f of x must also continuous at x equal 2. What is the meaning of continuity or continuous? Continuous means, if we learned before about limit, we have the limit, and the limit is equal to the function itself at that point. Okay. So continuous means, let me write here the general terms. We need to have this. Okay. We need to have this. Okay. So f of 2 let's say we are going to evaluate from the right side, that is equal to limit x closer to 2 from the right of the f of x. Or this is going to be for x plus b. So we get this is 8 plus b. And we know that f of 2 from the other equations that we have from here, from this x squared, okay? So f of 2 for x plus 2 is equal 2 squared equal 4. Okay, so this whole thing here should be equal 4 equal 8 plus b. So b should be negative 4. Okay, so the key components: differentiation, left, right, and continuity. Okay, continuity. Well, perhaps if you think you need to more practice on this, maybe after quiz, maybe next week, I'll start giving you another exercise and the solution, video solution. Maybe like 5 or 6 questions. Okay, any questions from this part? Any questions? Any questions? I think okay, right? Okay, right? Okay. Do you still need to take notes or finish? Okay, I think I will give you more, maybe 2 or 3 more questions to start off the lecture before we continue the chapter. Okay. So let me start with this, maybe this. And wait, I think this, no, this is too difficult. Maybe this one. The difficult one will be the last one, okay? Maybe 2 questions. Oh, sorry. I think the second question is similar, I think, from what we did, the tangent line. The first one, we have exponent, but it's e, so it should be not really complicated, supposed to be. We are using the composite function, the chain rule. We wait for maybe 3-5 minutes just to check whether you are able to solve it. can start from any questions. You can start from the second one, and the first one, or the first one.
The second is x equals 9. What about 9?
Hmm?
What about y?
Do you need y?
9.
Yeah, equal 9.
Yeah, and y. Oh, even.
Yeah.
And it equals 0.
What's 0?
No,
You don't need y for that. You mean like a point, right? X, y? But no need y.
It's so important.
Okay. The problem is this with x squared and secant x is like one group. So when you have this, the triangle said that you need to deal with all this. I remember the product rule. The product rule. So x squared f and secant x is equal to f prime d plus d prime d. I think that's the mistake. Yes, yes. This one is non-linear. But I think you're already correct. It's just this here. The first one, x squared secant x. Temporal. Yes, it's part of it. Now remember that this is outside one and the x squared so you can start with derivative of the outside and multiply with derivative of the yes, and then yeah, x squared minus yeah. You can insert the point x equal 9.
Oh, yeah.
Yeah, if you can, this is equal to point.
So it will be just
Yeah, 3, 9, 7. Yeah, put x equal 9 inside. I mean, this one.
Yeah.
27 over 3. I think this one needs to be. So first is.
Just slope it into relative in this one.
Yeah, you need to do this 9. I mean, over here. It's 9. So you have 3 over. Yeah. This is supposed to be 1, right? 1. Yeah, and this is supposed to be 1 x. So
X plus 19.
x plus 11.
Plus 11.
Yeah. Yes. Put in the point. Put in the point. Put in the point here. You get 9 here. Which means will be you can compute y, and then you can compute.
Because I think that I found 11 incorrectly.
Let me check.
So I got the correct answer in the incorrect way. Or I thought like this. So we got the slope and x. This is slope. And it's correct really because that's 1, that's 9, that's 11. Oh, so it's correct. Because I just have to change this by 1. X plus. Oh, so
You're really correct. Yeah. Okay, for the first one, imagine you have, let's say, a function g, okay, let's say e to the x, and a function h, okay, which is x squared secant x. You can think of that the f is actually g, or we say h of x inside of g, right? Okay. So what we are doing here is we are going to differentiate g, which is the same thing as it is, but we are just taking x and precisely this is the same original function. But we need to multiply with the inside function. Okay? So remember that this is the outside function or the outside layer, and this will be the inside one. Now what we are going to do is we are taking the derivative of the outside function, which is the same thing as this, multiply with the inside function, derivative. So we take derivative is e x squared secant x, right? And then multiply with the derivative of x squared secant x, which results in we take the product rule. So this is f, this is g, or we can also use another one if you confuse. This is u, this is v. So you will have u prime v plus v prime u. So x squared secant x tangent x. I think we can stop here. That's the answer for the first one. Okay. Okay. As long as you can identify which one is your layer, the outside inside function, every chain rule formula, as long as you know how to derive the original equations, the original formulas. Like you have the power rule, you have the product rule and everything, as long as you have that, all the chain rule formula you will be able to solve. Okay? As long as you can observe and identify. The second question, I think we can start with the question that asked before, what is y? We can just plug in the x. We can just plug in the x. So at x equal 9, y is 20, right? And then every time we have the tangent line, the first thing we need to take is find the slope, which is the derivative. That's the first step, every tangent line. Okay. So the slope, the y prime, is equal 6, right? And the slope at x equal 9, or y prime 9, like that, this is equal 1, right? So we have the m is 1, or slope is 1. We can write down the formulations. 1. So we will have x minus 9 plus 20 is 11, correct? So we have this. Okay, I think one more question. One more question. Let me write the questions. I forgot to copy. So let Rx is this is just to exercise the chain rule formula. Okay. This letter is G, okay? G. If you're wondering why my G is my that's G. Big G. I don't know why it's from I think since I was little I wrote G like this. I know it seems classic. To get through with this is perfectly similar. Like yesterday, I wrote the three combination function. So again, you can it's like cutting onion. Start from outside and going inside. Start one by one. The F and then G and then A. And then all these numbers, just focus the numbers at the end, okay? And plug in at the end. I think that will be better. If you focus on the middle or the early process, I believe there will be slight mistake on your calculation. But it's for example.
The product goes from outside to inside. Now when you're front, it goes from inside to outside. So you have to look for agents. Take this. Get this too. Goes in here. So it's you have to.
You can just text it.
Yeah. Yeah.
Okay, okay. I think one way to get through this and getting familiar really fast is, I think this is something that maybe your mind couldn't think through. You have function inside the function and then inside the function, right? So my best advice or my tips for you, if you feel that this is really not comfortable, you can symbolize with any symbol. Okay? You can symbolize with the A, B, C, or even with symbols, because we are not really defined anything yet. It's like a dummy symbols. We can define this maybe like a circle, like a triangle, anything. Okay, anything. In math, it's okay for this dummy symbols, dummy variables. So let's say we take this as A. Okay, take this as A, and let the A is a function. Okay, so we have f of A. Okay. Okay. So if I have Rx is f of A, then the R prime is f prime A and A prime. Is that correct? Okay. Okay. Is it more easy to understand? Okay. Now you know that A is the whole thing here, G, which means that we are going to find A prime, which is the differentiation of the G. Okay. So take your time. Getting familiar to all this is really takes time. Actually, for me, it takes years to getting used to this. But perhaps if you have like practice exercise, you will get through. Okay, you will get through. So we have this, which means that we are going to find that if Rx is f, then the R prime is f prime, this outside, right? And then multiply with the inside, which is this. Okay? So start from this, okay? And then we can start from this G, H, so we'll have G prime, H of x, and then H prime, right? Okay? And if you feel like, I feel uncomfortable with all this, you can take this as B, as easy as that. If you have like something that's really complicated, and you can simplify with the symbols, with anything that you have in mind, you just take that as your dummy symbols. Okay? You can always take this like a circle, square, triangle, anything. That's what I do. Like when I'm still in high school, I will take this like a square because I think it's cute. And I usually take square, triangle, circle because I used to play a PlayStation. Okay, and then we get this G prime H of x and then H prime of x. Okay, now we have our R prime. Now the question, we are going to put R prime 1. So we put 1 inside. Okay. And then now we can start looking our numbers. Okay. That's right. And I hope you can getting more familiar with the chain rule process. Okay. No matter how complicated it is, as long as you can identify which one is your layer function, I believe you will be master your calculus. Okay. Really fast. Okay. So H1 is 2, so this becomes 2. So G2 is 3, so this becomes 3. f prime 3 is 6, so this whole thing is 6. And h1 is 2. G prime 2 is 5, right? And h prime 1 is 4. So we have 6, 5, 4. So r prime 1 is 6 multiplied with 5 with 4. It's 120. Okay, any questions? Any questions here? Well, I think I can prepare more exercise and give you more video solutions. Okay? And if we need to take like review again, maybe after we finish all the techniques for differentiation, because at the end the question will combine some of the techniques. So I think I will give you more exercise. So what I want to say here is I think the matter of the calculus is the more you familiar with techniques and with the, at least not the techniques, at least how you see the functions and how you identify, observe, that will be, I think, key points to understand the techniques. So like you have a fraction, and then your mind should think like probably we can have quotient rule, or if you can rewrite into another form, maybe you can write first. There will be more and more ways to solve this derivative. Okay. And I don't know, somehow if you feel like at some point you get excited at this derivative, you will get addicted and you will need to find, is there any question more? You will see like maybe make more variations, more enjoyment probably. Okay, that's, I hope I can make you feel the same way. Okay, I hope. So every time you see questions, don't be nervous, don't be intimidated, but just think, or maybe you can laugh first. You can relax, and then okay, I will take it down. Okay. Okay. Before break, let me just give you some introductions to the next section, which is the logarithmic derivatives. Okay. The logarithmic derivatives, if you remember, remember that we learned that we have this, right? We can take this derivative, which means this is differentiable. Okay. And the log, if you remember, the log is the inverse of the exponential, which means it's supposed to be differentiable as well. Now we need to prove the log. Okay. So let me write in the new words here. So let y. So this is new functions, different from the previous one. So this is log. Let's say we have base b of x. Now if we want to take this in the exponential, this will be b with power of y equal x, right? So we take this and differentiate with respect to x, and we have implicit differentiations, right? So we can differentiate dy. Okay. So this will be by L and b, right? And then don't forget to write the dy over dx. And then this will be equal 1. So dy over dx is equal to this. Okay. Now b with power of y is our function. Is our x. So we can also change this into x. Now what's happened if b is equal e? Then ln b or ln e is equal 1, right? So then d dx of the ln x is equal 1 over x. If b is e, then ln e is 1. Okay. So every time we have log for ln, that means that we are going to take reciprocal. This inside function will here. So you can imagine if we have different functions here, it means that we need to multiply this angle. Same thing as before. Okay. Same principle, same principle. And usually in terms of questions, usually we are going to use mostly in terms of ln, not in terms of log and base function. Ln is good because frequency is only of Okay, we will have a break, so we can continue after the break. Okay. Any questions on this? Any questions on this one? I want to know who are who's still confused on, not confused, maybe still having difficulty on the chain rule. I know. Do you have? Do you still have difficulty on the chain rule? I just would like to know the numbers. Oh, really? Okay, thanks. Thanks. Okay, I just would like to know the chain rule. Okay. So perhaps maybe I will give you more practice and perhaps some tips. Okay, and since we are now at the logarithmic derivative, there's something interesting on here which we are going to look at later. But before we move to the examples and practice, if I have the functions, let's say the functions is, so if f of x is ln the absolute value of x, okay. can we think on what the first derivative looks like? And this is important for the ln. This is important for the ln because this will take the definitions for the ln, especially when you learn the integration. This will be very important. Remember, if we take the absolute value, it will have some part that is positive, some part that is negative. Right? And of course, if we take absolute value of x, only this part, the only point that distinguishes the two sides is x equals 0. Right? When x equals 0, of course, it's not differentiable, right? And when x is positive, it goes here, x negative here, right? So we can take this and see the implications to our function. So this will be, so it will be equal to x if x is positive, and this will be equal to x, negative x if x is negative. So let's say we have this. We have this definition, which means that if we have ln, we will have ln positive x like that, and ln that is negative x. So this is f of x. So this is if x is positive and if x is negative. Which means if we take the derivative, we will take the derivative first part, and then we take the derivative of the second part, and see what's the difference. Is there any difference or not? Or not different? Okay, remember, ln x is, we need just to take this and it becomes 1 over x, right? So no problem here, simply 1 over x. So what about this? So negative x becomes going down. Multiply with the chain rule of negative x. Negative 1. Should be equal to? Or let me write. Okay, be confused. Let me write. So f prime x. So first case, this is not a problem. This is just 1 over x, right? Second problem. This will be 1 and then negative x, right? And then multiply with the chain rule, which is negative 1. So it's going to be the same, right? It's going to be the same. So when you have absolute value of x, you will get the same result for the first derivative, which means you need to be careful when you learn on the integration or anti-derivative. If we have 1 over x, it means it can be two things. It can be ln x or ln negative x. So that's why later when we take integrations, it will be the ln with absolute value. But that will be later. This is to show you that when you have the absolute value, when you derive, it's going to be the same result. And if you check the graph, if you check the graph, okay, if you check the graph, this is f, the ln, this is ln x, this is the mirror, ln negative x, and this will be 1 over x. And if you remember how we observe the graph through the slope, you can see the slope is going to be here, and the slope here is going to be here. Okay? So interestingly, the first derivative, they will be the same 1 over x. Okay. Now after this section, I would like to show you why this log or the logarithmic derivative is really important and really useful in your pretty much most of the derivative questions can be solved for the log, and it will be really, really helpful. First, this log and implicit differentiation can help you to prove most of the basic techniques on your derivative. Let me show you. Okay, let's go back to the power rule. We have this. Okay, so we can prove this using the log and implicit. So take the ln, okay, take the ln, y, and because we have ln, then all the power can be moved through here. And remember, ln y, we have implicit, we have logarithmic derivative, so we can differentiate it. So let's differentiate this, okay? So ln y becomes, or maybe let me write the n and move n goes here, okay? And n is just a constant, any real numbers. So we take the ln y becomes 1 over y, and don't forget to add dy over dx. And this will be n multiplied with 1 over x. Okay, so dy over dx is equal to y n over x. And y is x with power of n. So this will be equal to x. And we can write n, x, n minus 1. Okay. Well, of course, this is, I think you already know how to derive this. It's pretty basic one, right? But how about if we take another function as well, another technique as well? So let's take the, let's say we take the product rule. We have f and g. And all the components are function of x. Okay, we can differentiate all of them with respect to x. Okay, so similarly we can take the ln at the front. Okay, and of course, getting through this means you need to remember property of logarithmic. Okay, some property of logarithmic. So when you have multiplication inside the log, you can separate this, become plus. Right? Become plus. Okay? If you have a fraction, you can separate, become minus. Okay? That's basic property of log. And it will be really helpful if you have any difficult functions that you think that you can divide them or separate them with log, then add log. Okay? And the process is just like this. You take the implicit, and then you solve the dy over dx, and you get the answer. Okay? I think it really helps. Okay? We look at the product rule now. So we take this with the implicit. So we take 1 over y, dy over dx, and then, or let me, maybe this will be, let me write this a little bit down here. And let me write the ln f plus ln g. Remember that f and g is a function, which means we are going to take this with respect to x. So it will be 1 over f. And then chain rule, f prime. Okay? So we are going to have 1 over f, and then f prime plus 1 over g, and then g prime. And then dy over dx becomes, we need to multiply all with y. Y is f of g. So you have f prime g plus g prime f, your product rule. Okay, and for the others, you can also do the same thing like the quotient rule and other basic formula. Then I think we can take this as the log. You just add log implicit differentiation. It's kind of like cheating, but it works. And the way we solve calculus, we can solve in many ways, and you can choose which method you prefer. Because sometimes you prefer to rewrite the form first and then you take differentiation. Or you take the derivative directly and you get the answer. Supposed to be the same result. So any methods you can choose. Okay, like example, let me write some complicated functions like this. Example. So y is okay, like crazy numbers like that. It seems that, oh, it's really complicated. Right? But we have now our friends log. It can help you. It can help. If you take log or ln, we can separate this and all become ln minus this one. Right? Okay. So take ln. So take ln, let me write slowly, and maybe let me take it a little bit down here to make it similar. Or maybe let me take x squared plus 1 is half. Okay, so calculus or mathematics in general is not how you can solve quick, but you need to solve precisely. Okay? If you want to like rush out your like, I see some students like from recent years, maybe because they are nervous, they want to solve the questions as fast as they can, but they don't have any like really clear objective where they go. They will like compute everywhere. They don't they don't see the path. Okay? So what I want to build, at least in our class, is you can identify and you can see the path. Okay? It's okay if you take time slowly, but you get the logical reasoning, the clear path, and the clear objective, and you get your goals. Okay? I think that is also the rules in life, right? So I hope you get your objective when you graduate from university. You can say you want to work at somewhere, industry, blah blah blah, right? Okay. So take the ln, and now we can, let's say this part here becomes one big ln, or maybe let me write here to give you some remembrance that if we have ln a over b, this will be ln a minus ln b, right? So we can write the same thing. Ln y is ln, write slowly, and then minus the ln of b, 3x plus 2 to the power of 5. Okay, this part we can also separate, becomes our ln. So we can also take this. So if we have ln a b, this can works like this. Okay. So ln y is ln plus ln okay. We don't even really calculate the calculus yet. This is all algebra. You just rewrite things first. And now we have power. We can take this power to the front, okay? And become a constant in the front. Okay? So we can take that. Okay, now after all of this, then we can differentiate. It's a long story, but take slowly. You get the idea at least, right? So take derivatives, and we will get the implicit differentiation. So take this and compute the derivatives. So 1 over y dy over dx. And this will be 3 over 4x, right? And this will be half of 1 over x squared plus 1 multiplied with 2x. And we can cancel this. So we have x over x squared plus 1. And then minus 5. ln 3x plus 2 is become, this will be over 3x plus 2. Don't forget all the chain rule formula we have. And we need to multiply with 3. So we get dy over dx is 3 plus x minus 15.
You multiply all of this.
Yes, with y. It's ugly, but it's doable, right? It's doable.
Yeah, of course.
It's ugly, but it's
I also
doable.
stop on this. I don't want to.
Yeah. And yeah, you can exchange your y and becomes the messy equations. It's crazy, but if we take slowly, we arrange first, okay, we take and separate first, I think it's doable. And that is why the log is really helpful. And sometimes I would like to say this, most of the derivatives can be solved through this log. Whenever you feel, okay, how to do this, especially for power. So if you see any functions and it has power, another function, one thing to be sure is take the log. And we will bring the power down. And you can differentiate implicitly. Okay, differentiate. Yeah. It's okay. I don't want to give
You want to count this?
more.
Let's say it, bro. Yeah.
It's okay. This is okay. Don't need to simplify the dividends because it's useless for what, right? This is like, I just want to know how the process is. The result is, I think you split it as this. Okay. Any questions? Maybe I would like to know if you feel not really familiar with the log. Anyone? One? Any other? Two, okay. We want to be for sure for log property. In my basic math class, I will cover that. But if not, you need to review. Okay. At least your, I think high school note. You need to review the log property. Yeah, another property from here that is worth mentioning is you have ln a b. This will be equal b ln a. Okay, this method with log usually will be powerful for examples like if you have y, x with power of square root of x. Now functions with power of functions. So we don't even know what other methods that can solve it. One way to go is we need to bring down this function to the front with log. At least we will get square root of x and ln something, right? And we know that this will be product rule in some way, and we can differentiate it. Okay. So every time you see a power, and maybe you think that, okay, I think I can bring down the power, take the log. Maybe it will happen. Maybe it will happen. Especially for function with power of function, for sure it's supposed to be using log. You take the log, you differentiate. And you will notice something, whenever we take log, when we implicitly differentiate, we will going to have another y, right? Because ln y will be 1 over 1. So your result should be equal to something multiplied with the original digit. There is some pattern that I think you can take that as some function. So you can guess at least what kind of solution you will have. So take the ln, take the ln, so we will have, and then take the derivatives. So this will be 1 over y, dy over dx. And then don't forget that we have two functions at least here. So we have product rule, right? So we take the first one and then plus. So dy over dx is equal x Okay, you will notice that whenever we take log for y, we will always have some multiplication with the original. This is some pattern that you will notice every time you do the log. Especially for a function that is functions and then power with another function. This will be the pattern. You will see its own equation, which is similar to what we have in the exponent. When you derive exponent, you get your other original equation multiplied with something. And aside from video solution, I think I also give you some video explanation for some section that I think I will skip for a while because it's just additional notes and not really important to what we have. Let me give you another example, and perhaps if we cannot finish by today, I will continue by next week. So let me give you another example. Find an equation. Let me give you another tangent line so you will be familiar with this. To the curve. Maybe give you a little bit complicated, okay? Y e sine x equal x cosine y at point 0, 0. So this will be the curve. So this is the curve, this is the point. Okay, take your times, and I think if we cannot finish this, we can look at next week.
I think it's easier with Glenn.
I think you can do it directly because I think e with power function is supposed to be easy. It's just using the implicit. I think you can try using LN. Yeah, no, all implicit. Yeah, correct. I think you can just directly derive using implicit. I think it's also fast. No need to take. Well, you could try adding log as well, and you could separate some functions. But I think if you don't mind, you can just derive directly using implicit differentiations. So you will see this. Okay, you will have two product rules. Okay. This is product rule, first product rule, and then second product rule. So you have something plus something here, and then it's like fg, f, and then adding dy over dx for your implicit. So dy over dx becomes your slope. Okay, and after that, evaluate at x equals 0, that is your slope. So differentiate, so implicitly derive. This will be dy over dx, e sine x plus y, e sine x, and then cosine x. And again, the same thing here. It's cosine y plus x so we can combine all dy over dx together. Remember our goal, okay? Our goal is not to simplify this equation. Our goal is to take the slope. I mean, you can stop here and then just plug in the point 0 and 0. Plug in point 0, 0. So you can stop here and plug in the point x equals 0, y equals 0. Plug in here, 0, e 0, 1, 0, 0. 1, 0, 0. Okay. Okay, let me repeat, okay? So, our goal not to solve this into simplified equation. Our goal is to find the slope, right? So we need to put x equals 0, y equals 0 as in our given point, 0, 0. So put x 0, so become 1, let me write, okay, 1. This is 0, right?
So wait, don't
1. And then this will be 0. Okay? So clear objective. Okay? Always remember what you are going to do. Okay? So no need to simplify. Stop here and okay, take x0, y0. Plug in all here and you get this.
So e and 1.
So dy over dx is equal to 1.
Yeah.
Okay? Okay. So it seems that, oh, what happened here? Oh, we need to still have finding the tangent line, blah, blah, blah. Actually, we take the point of x, I think we get more simplified.
The function, yeah?
Yes. So dy over dx equal 1. So yes. Right. Okay. So always remember when you state the questions, always remember what you're going to do, what you need to find. If you want to find the slope, then you need to remember what point you need to plug in. Okay? Sometimes, I know sometimes when you're in the middle of the process of this, okay, I need to solve this. But remember, sometimes in exam, your time is limited, right? So I think the best way is to rethink your question and, okay, I think you can just plug in here. So your slope is 1. So your tangent line is y equals x, right?
Yeah. 0 equals x.
So the tangent line is y equals x. So this is the tangent line. Okay. Okay, well then I think I will stop here. I do have the feedback